So in this example, we're given a simple circuit that has two current sources and a voltage source, and we're asked to find the power delivered to the 3 ohm resistor. So in this case, that's this resistor right here, and they're asking to do this using superposition. So using superposition approach. So in that approach, we consider each source separately, what the contribution from each source separately is. Since we're looking for power, we'll recall that power is equal to the voltage times the current. Now we can invoke Ohm's law here, and we know that voltage is just current times resistance, right? So if we can substitute that in, then still multiply that times the I, so it would be I squared R. So we already know the R in this case, so if we can determine the I or calculate the I, plug that back into that equation, then we should be able to solve this pretty easily. So let's apply superposition. So to do this, first we want to consider the voltage source. So when we do that, any current sources that are left in this, that are also in the circuit, we treat them as open circuited. So in that case, it's like those two aren't there, so we just delete those out. And so we can calculate this pretty easily. If we were to redraw our circuit, it's our 4-volt source, and we just see that we have our 3 resistors in series once we do that. So you can see we just come around and see those 3 in series. So that being the case, we can just use Ohm's law to determine the current from the 4-volt source. And so that's going to be equal to the voltage over the total resistance. So that'll be 4 divided by 2 plus 5 plus 3. And calculate that out, and we get 0.4 amps. So that's the contribution from the voltage source. So now we want to consider a different source. So we will now go and look at this 4 amp source. So we'll calculate that here. Again, current sources are open circuited, but now we have a voltage source. And so in that case, since we're not considering it, we treat voltage sources as a short circuit. So we would short that circuit out. And so now what we find then is we will have our current source here, which is 4 amps. It's in parallel with the 2 ohm resistor, which is then in parallel with the 5 and the 3 ohm resistor. So we're trying to calculate I, which is going through the 3 ohm resistor. So we want to know the current through this branch. So when we look at this, we see that it's really just a current divider. And so we can apply the principles of current division. So the current from the 4 amp source, that's going to be the total current. We recall from times the resistance of the other leg, we'll just say other, the one we're not interested in, over our total. So in this case, we'll have 4 amps, and that's going to be the resistance in the other leg. Well, this is the other leg, the one we're not interested in, so it'll be 2 over our total. So that's 2 plus 3 plus 5. And when we calculate that out, we see that that should come out to 0.8 amps. So this is the contribution from the 4 amp source. So finally, we want to consider the 6 amp source, which is here. So again, the current source is open circuited, the voltage source is short circuited. If we redraw this, we see we'll have our 6 amp source, and that's going to be in parallel with the 3 ohm resistor, and then that's in parallel with the 5 and the 2 ohm resistor. So in this case, now since we're interested in the 3 ohm resistor, this is the branch we're interested in. So this would be the other branch that we'll use in the numerator of our current division equation. So again, we'll come down here to calculate this source, and this will be I from the 6 amp source. And so in this case, this current is in the opposite direction from what we had before, and it's actually working against our circuit of the other two devices. So that being the case, we'll make this a negative, and the total current is 6. We said the other leg resistance is going to be 5 plus 2, and then the total resistance is 2 plus 3 plus 5. So when we calculate that out, we come up with a minus 4.2 amps. Again, the direction is indicating that it's working against the other two sources. So now we can calculate a total current, I total, which is going to be the current from the 4-volt source plus the current from the 4 amp source plus the current from the 6 amp source. And so we add those up at 0.4 plus 0.8 minus 4.2. And we add that up and we should have minus 3 amps. So this is this current right here. And we can take that and plug that into this equation here to determine our total power in the 3 ohm resistor, which is what they asked. So when we do that, then power in the 3 ohm resistor is going to be I total, what we called I total, times the value of the resistor itself. So in this case, that's going to be minus 3 squared, and then the resistor is a 3 ohm resistor, so that's the 3. Let me write this a little better, 3. And so when we calculate that out, we get 27 watts. So this is the power delivered to the 3 ohm resistor calculated using superposition.